number of rules for limits. A lot of them are intuitive. It's pretty obvious what is the answer for each of these, so we'll go through them one by one and just do a quick explanation. So if we've got two functions, f of x and g of x, and a, k, l and m are real numbers, and these two limits exist, so we've got the limit as x approaches a of f of x is equal to L, and the limit as x approaches a of another function g of x equals m, then we have a number of rules that we need to keep in mind. So from that we know that the limit as x approaches a of some, now k is just a real number, so it's like a scalar quantity, of that times f of x. Well, the k can come out the front and we get k times the limit as x approaches a of f of x. So that one's pretty straightforward. So if you've got a number times a function, the number can come out the front and then find the limit. The second one here, now it applies to both the positive and the negative. So the limit as x approaches a, now we know that the limit of each of the individuals exists, so that'll be equal to the limit as x approaches a of f of x. Now it'll be dependent, it won't be both obviously, it'll be just plus or minus, it'll be one of those. The limit as x approaches a of g of x, and we know that that from up above here is equal to L, and it'll either be plus or minus m. Okay, so what we could have written up here too is k, and the limit as x approaches a of f of x is equal to L, so that'll be KL. Okay, down here, so this is plus and minus multiplication, so that'll be the limit of the individual functions as x approaches a of f of x times the limit as x approaches a of g of x. Now we know that that's equal to L and that's equal to m. Here we have the quotient of the two functions, so that'll be the limit as x approaches a of f of x divided by the limit as x approaches x approaches a of g of x. We know that's equal to L and that's equal to m. Number 5, the limit as x approaches a of this function to the power of n is equal to the limit as x approaches a of f of x. So we can find that limit and then raise that all to the power of n. So we can either do that to the power of n, then find the limit of that, or we can actually find the limit of the function, then raise our n to the power of n. And that's just L to the power of n. Now this one's not so intuitive. So the squeeze theorem, and the squeeze theorem says that if we've got our function f of x, and we know that it will lie in between two other functions, so p of x and q of x are two other functions, and this one always lies in between. And if we know that the limit of this one, the first one, p of x, approaches L, and also the limit of q of x approaches L as x approaches a, then this one is squeezed in between these two and must approach the same value, L. And I suppose nothing like a diagram to show you how that works. So if we've got my function f of x, and say it goes a little bit like this, so that's f of x. We might move up here and get another pen for p of x. Looks like this. So here's my p of x, and my q of x looks a little bit like this. So here's my q of x. So here's my point A. And so you can see that if you know that the limit as x approaches a of q of x is equal to L, so here's my L value will be over here. So say we can't find this one because you've got divisibility by 0 or something else is going on, but you can find the limit as x approaches a for q of x, and you get L, and you've got another separate function that you can find the limit as x approaches a, and it's also L, so it has to be the same for both p of x and q of x. The limit must both be the same value. Then, because f of x, if you like, is squeezed in between the two, then it must approach the same value. So there's 6 rules that we should remember: squeeze theorem, power, quotient, product, sum or difference, and constant multiple.